Hello YouTube. So today, in this lecture, we'll be covering a formula or method of solving differential equations known as the integrating factor. So we'll be using the method of integrating factors to solve for differential equations. So in my previous video, I covered separation of variables, but that covers a very limited amount of cases. Not a lot of differential equations can be separated into this form. In differential equations, you have to learn how to solve a variety of different forms. So this is just yet another form of differential equation. So the form of differential equations that can be solved for it with integrating factors dy over dx plus p of x y equals q of x. So if it comes in this form, you can automatically solve using the integrating formula. So what is the integrating formula? Exactly, integrating factor formula? It's actually rather simple. So y of x is equal to 1 over u of x integral u of x q of x dx. And I know a lot of people might think that this formula will be complicated, and a lot of people in their differential equations class are too lazy or whatever. They don't want to have to memorize this formula, so they just derive it on an exam or something. Now, because I'm lazy, I just memorize the formula. So for brevity reasons, I won't go over the derivation of this, and also I'm just lazy. I don't want to derive it myself. So we'll just proceed without the derivation. So u of x is equal to e to the integral p of x dx power. So with this knowledge, it's actually quite simple to solve a differential equation that looks like this. Just plug it into the formula and you'll pretty much get it. So since there isn't really much else needed to figure this out, let's just go right into a differential equation. Let's say we have a differential equation dy over dx plus, I don't know, 8xy equals x. Okay, so how do we solve this? Well, first of all, let's find p of x. P of x is, well, as you can see, whatever is multiplied by y, so that's this 8x here. So p of x is 8x. Let me just write that straight. Q of x, what is q of x? Well, it's just whatever's on the right-hand side, so it's x. Okay, so we want to find what u of x is. U of x is just the integral. U of x is simply e raised to the integral p of x dx. So integral p of x dx is 4x squared. So that's our u of x. So we can plug it into the final formula here, where we get y of x equals 1 over u of x, which is e to the 4x squared power, times the integral of u of x. So what is our u of x? E to the 4x squared power. Then q of x, which is just x. So now we have e to the negative 4x squared power times, well, we could do a u substitution up here. So this is why so differential equations comes after calculus 2, maybe calculus 3 if you want. And that calculus is necessary for the so you need a calculus background to be able to solve differential equations, because oftentimes you'll need to be doing integrals, stuff like that. So here you could just set up a u substitution where u is equal to 4x squared. So that means du is equal to 8x dx. So you can just switch this up to 1 e to the 4x squared times integral of, well, here we have e to the u times this 8x here, so x dx becomes 1/8 du, so 1/8 du. Okay, that wasn't a very good view. So then we get 1 over e to the 4x squared times 1/8 e to the u plus c. But then u is 4x squared, so in actuality this is 1 over e to the 4x squared power times 1/8 e to the 4x squared plus c. So then our general solution will be 1 over 8 plus c e to the negative 4x squared power. Okay, so now that we covered one example, let me just cover one more example before I end this lecture. So I'll get rid of the formula, the example, so you can try to figure it out for yourself without the solution being right there in front of you. Okay, so let's say we have a differential equation dy over dx plus, I don't know, 3y equals, I could say 8x. Okay, so let's try to solve this. So we know that p of x is 3 because it's just whatever is multiplied by y. Q of x is 8x because whatever's on the right side. So u of x, using our formula, that's e to the integral of p of x dx. So that's just e to the integral of 3 dx, or e to the 3x. Pretty simple. So now we could plug it into our formula, which we remember as y of x equals 1 over u of x, integral of u of x, q of x dx, and that's 1 over e to the 3x times the integral of e to the 3x times 8x dx. Q of x is 8x. U of x is e to the 3x. So now we have an integration by parts thing. So this is 8 times e to the 3x times integral of x e to the 3x dx. So this is not a calculus lecture, this is a differential equations lecture, so I will not cover how to do the integration by parts, although maybe in a future video I will, but I'll just cover some of the steps that are necessary to do it. So this is 1/3 x e to the 3x minus integral of 1/3 e to the 3x dx. So then this becomes 8 e to the 3x times 1/3 x e to the 3x minus 1 over 9 e to the 3x plus c. So then our final solution, simplified, becomes 8/3 x minus 1 over 9 plus c e to the negative 3x power. Oh wait, sorry, there's an 8 here. There's an 8 up here. Yeah, so that's our final solution. Let me just, okay. Where c is an arbitrary constant, so whatever c is, you plug that into here, this differential equation, and it will indeed be a solution. Anyhow, thank you for watching this video, and I'll see you in the next lecture.